Hello, in this video I will show you how to solve question 9 of your assignment. The idea can also be used to solve question 10, 11 and 12. In this task you are required to find the shortest path from node 1 to node 5, and you are given the initial guess of f1 is equals to 8, f2 is equals to 7, f3 is equals to 11 and f4 is equals to 10. And the question is, what is the value of the measure of convergence after the first iteration? And you do the same for subsequent question to determine the measure of convergence. So let's look at the solution for question 9. So here we have the diagram as shown in the question, and here are the initial guess. So you make an initial guess, and we're using the dynamic programming algorithm to solve this problem. The first thing we do is identify the next iteration. So that will be f1 of 1, f2 of 1, f3 of 1, f4 of 1 and f5 of 1, which is a destination, so that's why it's equals to 0. What's the minimum path from node 1? So it would be either 2 plus f2 of 0 or 8 plus f3 of 0, and that's how we came up with this. You do the same for f2. So from f2 we have 4 edges out of f2, to 1, to 3, to 4 and to 5. We are trying to find the minimum path from f2 would either be 2 plus f1 of 0, 5 plus f3 of 0, 4 plus f4 of 0, or 12 directly to where we are trying to go to. And so we want to find the minimum. We do the same for node 3 and the same for node 4, and that gives us this general equation, which is the starting point when you are implementing the dynamic programming algorithm. These are our initial guesses. So you substitute the initial guesses into these equations, and so this gives you, for f1 we have the minimum of 9, 19, and for f2 we have the minimum of 10, 16, 14, 12, and for f3 we have the minimum of 16, 12, 16, and for f of 1 we have 11, 17, 10. And so for f1 the minimum is 9, for f2 the minimum is 10, for f3 the minimum is 12, for f4 the minimum is 10. So we now have the value of our new f values for the next iteration. This process is successfully repeated until the difference between, say, f1 of 1 minus f2 of 0 falls below an acceptable level. And to determine that, we use the measure of convergence. So we have D. In your notes, you're given that D of n is equals to the sum of fi of n plus 1 minus fi of n in brackets squared, and we find the square root. So you get the point. That's what we are trying to solve here. So we're finding the square root of the sum of the square difference from one iteration to the other. We have for f1 of 1, we have 9 minus 8. So the previous initial guess was 8, and this is 9. 9 minus 8 squared, 10 minus 7 squared, 12 minus 11 squared, and 10 minus 10 squared, and that gives us the square root of 11. And that is how to solve the first problem, which would be square root of 11. And then you do the same for the next iteration and the next iteration, and that's how to solve the remaining problem. That's a quick summary on the shortest route problem or shortest path problem using dynamic programming algorithm.